So the next part of tangent lines is looking at the converse of our first part. So if we have AB being perpendicular to segment OP, let me rewrite that. Yikes. So we don't know that AB is tangent, but we just know that it's perpendicular to our radius. Then we can say, so if we know that they're perpendicular, we have a 90, then we can say AB is tangent to our circle. So we're kind of working backwards here. So we're saying if we have a 90, then it's tangent. The other one said if it's tangent, then we have a 90. So we'll go on to see what that helps us find, which is our radius. So if I do have a 90 for problem 3, example A, that means that I do have, so I have the 90 here. So that means that AB is actually, so AB is going to be tangent. Let me erase that. That's not great. So if we know that, we can actually find the radius, which is x. And we notice that we have the radius here again, x. But we also need to know what this AC is, because we're going to be working in a triangle right here. We're going to be working in this triangle, and we need to know the full length. It's x and then 8 more, so it's x plus 8. And I'm working in a right triangle, so yes, we are using the Pythagorean theorem to find x. So if I look, I've got the sides, and my hypotenuse is AC, so it goes x squared plus 12 squared, so legs, the sum of the legs squared is equal to hypotenuse x plus 8, the quantity, squared. Now, finding that quantity squared means if I have x plus 8 squared, that means it's x plus 8 times x plus 8. There are two ways to multiply this. You can FOIL. I'll do that the first time. So it's like first times first, outside times outside, inside, last. So it's x times x, x squared. X times 8, so 8x, plus another 8 times x, so 8x, and then last 8 times 8, 64. So if I'm going to add all those pieces here, I got x squared plus 144 equals, and we're trying to get the radius again, which is x. So we're just trying to solve for x. And we get x squared, and I'm going to put this all together and get x squared plus 16x plus 64. Subtracting my x squareds because I want them all on the same side. Oh, and they cancel. Yay. That means I want to move the 64 to the other side. So I subtract 64. And I'm left with 16x, so x's are all by themselves, and 80 on this side. So I get x by dividing by 16 on both sides, and I get x is equal to 5. So that is our radius. X is equal to 5. Same thing with the next one. I'm going to have to use the Pythagorean theorem because I'm working in a right triangle, and my radius, but I look, what is this whole side of my triangle? It's the x, the radius, and then 6 more. So that means it's x plus 6 for one of my sides. So it goes x, so it's side squared plus side squared, so x squared plus 10 squared equals hypotenuse squared, x plus 6 squared. Now the other way to multiply x plus 6 squared, it's still x plus 6 times x plus 6. But you can use the box, and you put x plus 6 on the top, x plus 6 on the bottom. So x times x, x squared. x times 6, 6x, x times 6, 6x, and 6 times 6, 36. So that means when I write it all out, these are all going to be added together. And so I get x squared plus 100 equals, and then I've got x squared, 6x plus 6x plus 36. That's just going to be x squared plus 12x. I combine my like terms, plus 36. Then I subtract x squared from both sides so I can get it to one side and it cancels. Thank goodness. It'll always do that for you guys. And I also want to move all my numbers to one side, my constants, and I get 12x equals 64. And we're going to round for this one, and it's going to be 5.3. So my radius is 5.3. So that's, we're going to use the Pythagorean theorem again. So we don't know that these are, well, we do now know that they're tangent because they tell us we have a 90. So identifying whether we have a tangent, we're going to need to know if the Pythagorean theorem works. So let's look here. I have the triangle, and I'm trying to figure out, is ML, this guy, tangent to N at L? So basically, are we asking, is the Pythagorean theorem true? Probably would write is. So to figure that out, we take 7 squared plus 24 squared. Is that going to be equal to 25 squared? And we figure that out. So 49 and 576, is that going to add up to 625? And luckily for us, it does. It is equal. So since the Pythagorean theorem is true, that means we do have a 90 here, first of all. It's a right triangle. And so yes, ML is tangent. So if the Pythagorean theorem is true, it's yes. If it's false, it's no. So let's find out what's happening with this guy. So if NL is 4, and we're going to use the diagram, meaning we're going to just recreate that little triangle here. So we've got N, L, M. We're going to use the diagram to figure out if we had these dimensions, is this going to be tangent? So NL is 4, ML is 7, NM is 8. So with this info, is ML going to be tangent? So it's 4 squared plus 7 squared. Is that going to be equal to 8 squared? When I see this right away, I'm not convinced, because it's 16 plus 49. That is not equal to 64. So not tangent. So our converse really has to do a lot with things being perpendicular and working in right triangles, which means using the Pythagorean theorem.